right, we are moving on to chapter 8. In chapter 8, we still talk about our x squared terms. So we're going to have x squared. So these are called quadratic functions, our x squared. So in chapter 7, we were factoring them. In chapter 8, we're going to be graphing our quadratic functions. So a quadratic function is nonlinear, meaning that it's not a straight line. It's written in standard form when our highest degree comes first. So we've written them in standard form before. And it has a U-shaped graph. So it says the U-shaped graph of a quadratic function is called a parabola. That's just the name of the shape of the graph. In this lesson, you will graph quadratic functions where b and c equal 0. So our parent function is this graph down here. This is just the basic graph of our quadratic functions. The graphs of all other quadratic functions are transformations of the graph of the parent function. So if we just have x squared, our graph will just look like this, basic, simple. If we are adding numbers to the x squared or multiplying, our graph may shift or stretch or something like that. It may move somewhere else, but it'll always have this shape. It'll always be U-shaped. The lowest point on a parabola that opens up, or the highest point of a parabola that opens down, is the vertex. So the vertex is either at the tippy top or the very bottom. So this would be our vertex here. The vertical line that divides the parabola in two symmetric parts is called the axis of symmetry. So what does it mean to be symmetrical? To be the same on both sides. So in all of our parabolas, we're going to have an axis of symmetry where a parabola is the same on both sides. The axis of symmetry passes through the vertex. And our axis of symmetry is always going to be x equals. So it'll be a line. That'll be x equals. So in example A, it says identify the characteristics of the quadratic function and its graph. So here it's already done for us. We're going to be given the parabola. We have it here. It tells us that our function is decreasing on the left side. So we can tell if it's increasing or decreasing. Yes, sir, turn around. If you are reading a graph, we read it just like we read words, from left to right. You read a sentence going from left to right. So we read our graph going from left to right. So starting at the left side of our graph, if I was a person, and I started at the left side of my graph, and I was walking along my graph here, would I be walking uphill or downhill if I was walking downhill? So our function is decreasing. Since we're walking downhill, it'd be decreasing. Until we get to our vertex, walks all the way to here, then would we be walking uphill or downhill? Uphill. So on the left side of our axis of symmetry, we would be decreasing. On the right side, we are increasing. So here, it says when x is less than -1, so we're talking about the left side, y increases as x decreases. On the right side of our graph, our function would be increasing. So when x is greater than -1, it increases as x increases. So we're just going to be saying on the left, so in other words, on the left it's decreasing, and on the right it's increasing. Also on our graph, we're going to have to identify the axis of symmetry, which is the dotted line that goes right through the middle. Yes. So here, our axis of symmetry goes through where x is equal to -1. And then our vertex, we're going to have to identify that too, is the very lowest point of the graph. So our vertex is at -1, -2. Last two important things that we need to know here. Always for our quadratic functions, our domain is going to be all real numbers. So domain is the x values on our graph. Your domain is always all real numbers. The range is our y values. So we look at the y in our vertex, and our range is going to be all numbers greater than or equal to -2. So since the y in our vertex was -2, that's going to be the value that we use in our range. And since our graph opens up, that's why we say greater than. It's a lot of information just with one graph. We're going to practice this. Any questions here? All right, let's look at B on the next page. So we want to figure out our vertex, our axis of symmetry, where we are increasing and decreasing, and our domain and range. So our vertex is at the point of our graph where it's either the highest point of our graph or the lowest point. So here our vertex would be at the very lowest point. What point is that? What would the coordinate points be? 2, -3. Awesome. 2, -3. Perfect. And now our axis of symmetry is a dotted line that goes right through the vertex. And our axis of symmetry is always x equals. Think axis, x equals. X equals what number? What number did we go through on the x-axis?
2.
2. So x equals 2. Now let's figure out where we're increasing and decreasing. If I started on the left side, all right, so we want to figure out where we're increasing and decreasing. So just like how we read a sentence, we go from left to right. So if I was a person and I was walking along my graph, would I be walking uphill or downhill to start? We'd be walking downhill. So would we be increasing or decreasing? Decreasing. So we'd be decreasing on the left of x is equal to 2, because we're on the left side of our axis of symmetry. So then once we reach our axis of symmetry, it's going to change. Then once we continue to walk right, would we be walking uphill or downhill? Uphill on the right side. So we'd be increasing. So we're increasing right of x is equal to 2. Now we have the tricky one. Domain. What would our domain be? What did we say on the last example? What's our domain always? Go back to A. Go back to A. What does it say for A? Our domain is always all real numbers. All real numbers. And then our range, we use the y value. Because range, we talk about the y. What's our y value in our vertex? -3. Is our x, or is our y value in our graph, is it greater than -3, or are we talking about y values that are less than -3? Does our graph point up or does it point down? Our U shape, is it pointing up or is it pointing down? It's pointing up. So our range would be y values greater than -3. Because our graph is pointing up. We're going to do the same thing for C. So we're going to find all of those things again. We need to find our vertex, the axis of symmetry, we need to identify where we're increasing and decreasing, and the domain and range. So our vertex is either at the highest point of our graph or the lowest point of our graph. Here, since it opens down, it's going to be at the highest point. What is that point? What's the point of our vertex? -3, 7. Awesome. Goes x, then y. We're -3 on the x and up 7. Axis of symmetry is x equals, what is our x value that our axis of symmetry goes through? -3. So x equals -3. Now for increasing and decreasing, we start just like how we read a sentence from left to right. We read our graph from left to right. So we're going to start at the left side of our graph. If we're walking in the right direction, would we be walking uphill or downhill to start? Uphill. So we would be increasing. Are we increasing on the right side or the left side of our axis of symmetry? This is the left side. So we're increasing on the left side of x is equal to -3. Once we get to the axis of symmetry, then our direction changes. Then are we walking uphill or downhill? Downhill, so we'd be decreasing. So we're decreasing on the right side of x is equal to -3. Now, what is our domain? All real numbers. Domain is always all real numbers. On a test or quiz, that's going to be like a free question. You don't even have to think about it. Domain is always all real numbers. And then lastly, let's look at our range. Range is the y values. So we're talking about y values. What's our y value in our vertex? 7. So at 7, are we talking about y values that are above 7 or below 7? Does our graph go above 7 or below 7? What do we think? Looking at our graph. 7 on the y-axis is here. Is our graph above 7 or is it below 7? Below, and it's going down. So we're talking about y values less than 7. So a couple important things to know before we graph them is that we're going to have a number, a coefficient in front of our x squared. When that coefficient is greater than 0, meaning that it's a positive number, our graph opens up. It's like a smiley face. Think about it when you're positive, you're smiling. When the coefficient in front of our x squared is less than 0, meaning that it's a negative number, our graph's going to open down. So that U shape is now going to go down. It'd be like a frowny face. So it's a couple important things to keep in mind when we graph. So automatically, just by looking at the question, the first thing you're going to be able to tell is whether your graph's going to open up or open down. Is it going to be a smiley face or a sad face? Bless you. So to graph these, we're going to just plug in some numbers and evaluate. So we're going to make up numbers for x. We have numbers for x here. We're going to plug them into our x. F of x is just a fancy way of saying y. So we're going to get numbers for our y value and then plot those points. So it'll be x comma y as our points. And we're going to put them on our graph and then connect the dots and draw our graph. So starting with -2, I have 2 times -2 squared. What do I have to do first here? PEMDAS, what would we do first? Parentheses, but we don't have any math going on in the parentheses, so what would come next? What's the E stand for? Exponent. So we want to do the exponent. What's -2 squared? -2 times -2 would be +4. So we have 2 times 4. What's 2 times 4? 8. So our y value is 8. So our point would be -2, 8. Let's put that on our graph. We're going to go to the left to -2 and up 8. So that's our first point on our graph. Next, let's plug in -1. So 2 times -1 squared. What's -1 squared? 1. -1 times -1 would be +1. And 2 times 1? 2. So we plugged in -1 and we got 2 as our y. So our point would be -1, 2. So let's put that on our graph. We're going to go to the left to -1 and up 2. Next, let's plug in 0. 2 times 0 squared. What's 0 squared? 0. And 2 times 0? 0. So we plugged in 0, got 0. So our point would be 0, 0. So we're going to put a point at 0, 0. Next, let's plug in 1. So 2 times 1 squared. What's 1 squared? 1. 2 times 1? 2. So we got 2. What would our point be? 1, 2. So that means we're going to go to the right 1 and up 2. Lastly, let's plug in 2. 2 times 2 squared. 2 squared would be 4. And 2 times 4? 8. So we got 8. What would our point be? 2, 8. So we're going to go to the right 2 and up 8. Now we want to connect our dots. What shape is our graph going to have? A U shape. Our graph is going to have a U shape. So we're going to start at the first point that we found, all the way on the left, and connect our dots and make sure our graph keeps that U shape. It's not a V. It doesn't have a sharp point at the vertex. It's got a U shape. All right, so plug in -2 first. We have -3 times -2 squared. What would we have to do first here? What do we do first? We do the exponent. What's negative 2 squared? 4. So negative 3 times 4. What's negative 3 times 4? Negative 12. So we got negative 12. What would our point be here? Negative 2, comma negative 12. Perfect. We plugged in negative 2 for x, so that's our x value. And we got negative 12 for y. So let's put that on our graph. Which direction do we need to go on our graph to put negative 2, negative 12? Go to the left, negative 2, and then down to negative 12. Chris, what do we plug in next? What's next on our list? Nestor, what would we plug in next? Sam, what would we plug in next? Delaney. Negative 1. Next, we want to plug in negative 1. So we have negative 3 times negative 1 squared. What's negative 1 squared? 1. So we have negative 3 times 1. What's negative 3 times 1? Negative 3. Chris, what would our point be? What would our point be? We need two numbers for our point. Negative 1, negative 3. So let's put that on our graph. So we go to the left to negative 1 and down negative 3. Next, we have negative 3 times 0 squared. What's 0 squared? 0. And negative 3 times 0? 0. So what would our point here be? 0, 0. So let's put that on our graph. Got a point at 0, 0. Before we continue and plug in 1 and 2, just looking at our graph, if our coefficient's negative 3, do we know which direction our graph's going to open? Will it open up or open down? Down. It's negative, so it's going to be a sad face. So we already know that our graph's going to open down, so just keep that in mind when you're plotting the points. That way you know if you're plotting the points correctly or not. So let's plug in 1. We have negative 3 times 1 squared. What's 1 squared? And negative 3 times 1? Negative 3. So what would our point here be? 1, negative 3. So let's put that on our graph. We're going to go to the right one and down, negative 3. And then lastly, let's plug in 2. Negative 3 times 2 squared. 2 squared would be 4, and negative 3 times 4? Negative 12. So our point here would be 2, comma, negative 12. So we're going to do the right 2 and down to negative 12. Once we have our 5 points, what can we do? Connect the dots. What's the shape that our graph has to have? A U shape. Here it's just an upside down U. So that would be our parabola. So here we're doing the same thing. Our number out front is just a fraction, but that doesn't really change anything. Is 1/3, is it positive or negative? Positive. So is our graph going to open up or open down? It opens up. It's going to be a smiley face. So let's plug in our points. First, we're going to plug in negative 9. So we have negative, 1/3 times negative 9 squared. What's negative 9 to the second power? Negative 9 times negative 9 would be 81. So we have 1/3 times 81. So this would be 81 over 3. What's 81 divided by 3? 27. So our point here would be what? -9, 27, comma 27. So if we go to our graph, that's going to be way off of our graph, but we'll estimate. So we're going to go to the left to -9 and up 27. I'm just going to put it way up here. The rest of our points will be on our graph. Next, let's plug in -3. So we have 1/3 times -3 squared. What's -3 squared? 9. So 1/3 times 9 would be 9/3. And what's 9/3 simplify to? 3. So our next point would be -3, comma 3. So let's put that on our graph. We're going to go to the left to -3 and up 3. What do we plug in next? 0. 1/3 times 0 squared. What's 0 squared? 0. And 1/3 times 0? 0. So we get 0. What's our point going to be? 0, 0. So we're going to put that at 0, 0 on our graph. Next, let's plug in 3. 1/3 times 3 squared. What's 3 squared? 9. And 1/3 times 9 would be 9/3. What's 9/3 simplify to? 3. So our next point would be 3, comma 3. So in our graph, we're going to go to the right 3 and up 3. Last point, let's plug in 9. So we have 1/3 times 9 squared. What's 9 squared? 81. 81 times 1/3 would be 81/3. And what's 81 divided by 3? 27. We did that one earlier. So 27. So our last point would be 9, comma 27. So we put that on the graph. We're going to go to the right 9 and up 27, which again will be way off of our graph, but that's fine. And what's the last thing we need to do? Connect the dots. So we're going to connect the dots in a U shape. Our graph opens up. Did we say our graph was going to open up in the beginning? Yep. So we know that we did it right. It's just one way that you can check your work to make sure you plotted the points right. Your graph is going to be symmetrical, and it'll match. If it's positive, it's going to open up. If it's negative, it's going to open down.